Hello and welcome to today's SearchDataManagement.com presentation. Choose the right dynamic in-memory to turbocharge your SAP application software. My name is Don. I'll be the moderator for today. Today's presentation is being brought to you by IBM. The slides for today will be pushed to your screen automatically, and the audio will be streamed to you through your computer. If you have any questions today, you can enter them by clicking on the Questions tab, which is on the left side of the screen, and click on the Submit Question button. All questions will be addressed at the end of today's presentation. Joining us today is Carl W. Olofsson. He's the Research Vice President for Application Development and Deployment at IDC. Also joining us is Bob Frisk. He's the IBM Power Systems Marketing Manager at IBM. With that said, I'm now going to hand things off to Carl to begin his discussion. Please go ahead, Carl.
Thanks, Don, and thanks, everyone, for joining us today. Before I begin, I'd just like to let you know that I've been with IDC for 16 years covering the database industry, and I've been in the IT world since 1978, so bring a little bit of experience to the words I'm going to be sharing with you today. And today we're going to be talking about database technologies for the real-time enterprise. And what we're doing is we're considering DB2 as an option for the SAP Business Suite. So the subjects that I'm going to be covering today are going to include the real-time enterprise, what it is, what it requires, and then I'm going to be talking about what kind of database technologies are necessary in order to enable the real-time enterprise, which include in-memory, columnar compression, vector processing, and the ability to handle a mixed OLTP and analytic workload. And I'll explain why that is. We'll talk about considerations for SAP Business Suite, including choosing the optimal hardware and software, as well as looking at SAP Business Suite as part of your overall data center landscape and enabling the real-time enterprise. Then we'll have a look at DB2 with Blue Acceleration. We'll see how it addresses the requirements of the real-time enterprise, also how it specifically addresses the requirements of SAP Business Suite and fits into your existing configuration, and we'll wrap up with some conclusions and recommendations. So the challenge that we're dealing with here, and the reason that we're all talking about this today, is that, as everyone on the call is aware, I'm sure, that the pace of business is accelerating at a very dramatic rate. We're seeing the effects of online transactions of all kinds, which were triggered years ago, really, by Amazon, and continues to be the case today, with an expectation by consumers that they can execute transactions, have them take effect immediately, and receive results right away without waiting. Online banking has reduced what we used to call float time. No longer can you cut a check and have that luxury time it takes for the check to be transmitted from one bank to another and then honored. These days, with instant electronic transfers, the payments get credited right away. Online trading decisions. Online systems have become more and more sophisticated when it comes to trading in the stock market in particular. Gone are the old crude algorithmic trading programs that used to cause massive disruption in the markets. Now we have very sophisticated trading systems that analyze the behavior of the market based on complex recognized patterns. And in the globalization world, there are no more batch windows, which means that we don't have the luxury of being able to allocate lots of downtime for our critical online systems. Instead, they need to be available 24 hours a day, 7 days a week. So when we consider all of these things, what we see moving towards is the real-time enterprise. So what do I mean by that? Unlike the enterprise of the past that had business hours, that had its pace determined by a number of factors, including the computer systems themselves, these days the pace is driven by the market, and the enterprise needs to be able to respond immediately to changing business conditions. So as a result, we need to be able to act on events as they happen. We need to be able to change data and operations to fit the shifting business needs and to ingest large amounts of data, including from big data sources, so that we can make the data actionable, so we can take that data and respond to it immediately at the point of action. Such speed and flexibility require that we have processes and we have applications that are set up to match how the business is moving, how the changes in events and event processes are impacting the business, so that we can be highly flexible. So we can store and retrieve data at the speed of business, that the data can go right into some place where it can be analyzed and used within seconds of reception, and so that we can support real-time decisioning. So what do I mean by real-time decisioning? What I'm talking about here is being able to take decisions right at the moment when they need to be made, as opposed to sitting down after the end of the business day and reviewing what happened that day, or what happened at the end of the week or the month or the quarter or the year. Take a look at our business systems and decide what we need to tweak, what we need to change. Those actions still need to be taken, of course. We still need to do that kind of analysis, but in addition to that, we also need to be able to respond immediately at the point of actual tactical decision. There are three kinds of decisioning that are involved here. So there is the strategic, where we look at our deep analytic models and we review what's going on in the data warehouse, and we comb over lots of data and make recommendations to executive management regarding how we might want to optimize the behavior of the enterprise moving forward and the organization of it. We have operational decisions, where we're taking a look at data as it changes, take a look at the business as it changes. We're using various analytic tools to visualize what's going on in the enterprise and make decisions about how we want to adjust what's going on to better fit business needs. But then there are also tactical decisions, and this is really where real-time decisioning comes into play, where we're taking a look at immediately available current data. Often the systems that we're dealing with are driven by streaming data, so there's really no time to sit back and think. We have to just sort of take a look at what we have at the moment and act, which means that we need to be supported by analytic systems that can collect and present to us business intelligence of the moment that will immediately help us to make the right decision at the right time. So the real-time enterprise has certain specific requirements in order to be able to do the things I just described. It needs to be able to process fast-changing data. It needs to be able to deal with the data as it's in, as it's streaming, as it's changing. So we need a high-performance database management system that can accept data at the rate at which it is streaming in. We also need a high-performance database management system that can take data that's been ingested from a big data source through an engine like Hadoop and take the relevant data and make that immediately available to us. It delivers that data to us through real-time analytics using a memory-optimized columnar database management systems technology. And I'm that specific because that is the direction the entire industry is moving towards, is memory-optimized columnar database. And we need to be able to complement that with highly scalable transaction processing so that we can transact a business at this pace at which the data is flowing in and actions need to be taken. Now, all of that needs to be driven by world-class applications, and it needs to have underlying it a world-class data warehouse so that we can have a dynamic framework for making our analytical decisions and observations, and those in turn need to be running on top of a world-class infrastructure. So I have an image on the screen now that illustrates what the real-time enterprise might look like. It's obviously a highly abstract image. Not everyone is going to have all of these technologies, but in many cases, especially where we're dealing with applications that need to be responding to data of the moment, such as streaming data, this picture is fairly relevant, although, of course, highly simplified. And what we see is streaming data coming in, being processed through a complex event processing engine, and that complex processing engine is doing an immediate query. It may be a very complex query. It may be a query that has, I don't know, 12 or 15 nested selects in it to get the data that it needs in order to make a quick decision. And in some cases, that decision is automated so that the behavior of the business system is driven by an algorithmic decision that's based on, say, a pattern that's been recognized or a certain combination of facts that it's meant to recognize. In other cases, high-speed decisions are being driven right out of the memory-optimized database management system. The memory-optimized database management system, in turn, is getting its data from the Hadoop system, which is also ingesting the streaming data and reconciling that to its very large collection of already captured data and presenting us with data that has been winnowed out, that's been normalized to some extent, that's been put into a structured format that we can use for the kinds of processing and analyses that we need to do. And of course, at the same time, we're also feeding out of that memory-optimized database the data warehouse that we can use for making longer-range strategic decisions off of enterprise analytics, while at the same time having the ability to make operational decisions based on real-time business intelligence through our various analytic tools. So what are the database technologies required? That's actually what we're here to talk about. For the real-time enterprise, these are the database technologies that are critical. First of all, it has to have the power for high-speed analytics and for real-time analytics. And that means a very different kind of database system than we've been using in the past. We need columnar memory-optimized functionality. We need extreme speed for query processing. We need it to be scalable so that it can handle the mounting volume of transactions. We need it to be part of a larger whole. It must be integratable into the general data center database management portfolio. It can't be some odd technology that sits off on the side that requires special skills and knowledge to operate. Because otherwise the enterprise becomes difficult to manage. The data center becomes too complex, and the data center is already too complex, as I think most listeners realize. It needs to run on hardware that is consistent with the rest of the data center's databases so that you can manage the hardware as a whole and, again, not have to make special cases for particular pockets of the data center. And it needs to be manageable with a common skill set so that the skills that you bring to bear in other systems in the data center can be used for this particular kind of database management system as well. So let's talk about the in-memory database, and its acronym is IMDB. So what is it? Well, it is managed by a memory-based or memory-optimized database management system. And the term memory-optimized is actually a better term than in-memory database because the truth is that most of these systems are not 100% in memory, but they are mostly in memory or partly in memory, or the most active parts of the database are in memory. And they need to be able to handle the mix of memory and other storage, including disk storage as well. But the point is that their operations are entirely based on a memory-optimized strategy. So the data is fully organized and optimized for management in memory. And although it is different in architecture from the classic disk-optimized database management system, it is still fully recoverable, fully consistent, fully reliable, has ACID properties, all the things that you require in a regular enterprise database. What it does is it manages all the same kinds of data as disk-based systems. It supports the same SQL. It supports protocols, and it scales through clustering. And what it offers is very fast transaction and query speeds. It has very low administrative overhead, and it gives you great flexibility. The schema changes do not force unload-reload operations. So what we're talking about is a transition from the disk-optimized database systems that we've been used to for the past 40 years to memory-optimized database management systems. So what does that entail? From the perspective of data management on the disk, the old systems that were disk-optimized had complex maintenance operations. And I'm speaking in the past tense. Of course, most of us are still using disk-optimized databases most of the time for most things today. But we are in the midst of a transition. We're moving from disk-optimized systems and complex maintenance operations, which included things like unloads and reloads for various functions, such as defragmentation or reallocation of data across the disk, or because of a change in the partitioning scheme, or because of some other optimization that we've come up with to speed up our queries. We've reduced all that disk-based mapping and tuning. We've virtually, eliminated it. In the disk-optimized case, there's intense disk-based mapping and tuning required. It also underutilizes disks in order to deliver performance. As I think the DBAs in the audience will recognize, we want to lightly load the disks as far as the database is concerned so that we can avoid head contention, which is a key cause of slowdown in I/O performance of disk-based databases. And we can use disk-optimized systems for more long-term, large database management where performance is not critical, but it's really inappropriate when it comes to the kind of high-speed database that we need for the real-time enterprise. By contrast, we have memory-optimized database management, and that's, of course, what we're talking about today. In this case, the database management system execution is much simpler. There's no disk-based tuning. There are no indexes in many cases. Or on the row-based side, there may be indexes for primary key and for foreign keys, and that's it. They require much less administration as a consequence. And they deliver rapid database management and retrieval, which is critical for the real-time enterprise. So the benefits of the memory-optimized database management system, obviously there's speed, and that's what everybody talks about first. The transactional databases typically run at least 10 times faster, and I have seen tests run on systems like this in which their analytic processing improves from 40 to 200 times. We've seen high transaction rates, which enable the database to be used for real-time applications, even ones that are driven by streaming data. We've seen fast query times, allowing reports and queries and visualizations that used to take hours to build, now take minutes. And in fact, I would say that we have found in some survey work that we've done that people have reported between time intervals between days and weeks to set up and deliver analytic reports, and those can now be done in a matter of between minutes and hours, depending on how much database change is required for the report. The costs, there's no more unload-reload operations, index rebuilds, disk redistributions, and backups are much simpler now because they consist in something more akin to a snapshot than a full multi-volume disk backup. So the operational costs associated with the database management system is greatly reduced because the storage operations are greatly reduced. And this gives us a lot more flexibility. It means that we can change schemas more readily without worrying about the massive impact that it has on the whole system and how long it will take, and we have to quiesce the database for a long period of time as we reorganize it and so forth. The enterprise can bring its full complement of data to bear in solving business problems that could not be addressed before because, quite frankly, the database was too slow. And I would even point out that there are routine operational benefits as well, such as simple things like database loads, for which batch windows are increasing all the time. These run much faster in a memory-optimized system. So now let's take a look at the issue from the perspective of SAP Business Suite. It's important to choose optimal hardware and software for database management, obviously. SAP Business Suite is also in a process of evolution, and it is evolving towards a real-time enterprise. It's evolving towards a state where you want to be able to coordinate the behavior of the application with real-time decisioning. You're going to need to choose the optimal hardware and software for database management. Some of the options may require a fixed configuration of hardware and software to support SAP Business Suite, and you need the flexibility to ensure that the resources more effectively address it across the portfolio. If you include SAP Business Suite as part of your data center landscape, then that application is generally critical to your business operations. So integrating it with other application functionality may be key. And I mention all these things because if you use SAP Business Suite with a data management environment that isn't well integrated with the rest of your data center, you may be inviting additional work for yourself in terms of integration effort. Now let's talk about DB2 and the blue acceleration option. First of all, we can see that it meets the requirements of the real-time enterprise because it does deliver memory optimization with columnar acceleration, and it has vector processing to deliver optimal query performance. It also delivers scalable transaction support. It integrates well with other key elements of the real-time enterprise configuration because it's DB2, and as DB2, it has compatibility with a great many different systems that you may use in your enterprise, whether they come from IBM or from other vendors. It runs on standard data center hardware, and it's optimized to run on IBM power systems. So that's a thing to consider as well. And it's certified and supported for SAP Business Suite. So if we look at the IBM product portfolio in terms of the real-time enterprise, it comes out looking something like this. And this isn't an exhaustive illustration, but it just suggests how some of the products plug in. So we can see that we have DB2 with blue acceleration is right there in the memory optimized database slot, and it's feeding, it may be feeding, say, pure data for analytics if you want to go that route. You may be getting your data from pure data for Hadoop system, which in turn is being fed along with the CEP engine in your application environment by InfoSphere streams. And all of this is feeding into the SAP Business Suite and allowing it to operate in an optimal manner. So in conclusion, enterprises need real-time enterprise strategy to address the requirements of fast-moving business environment. Memory-optimized technology, future of database. Everyone is moving in this direction. The kinds of technologies that I was describing are actually the ones that are being adopted and accepted as the standard going forward. You do have a choice of memory-optimized options to use with your SAP Business Suite. It shouldn't feel like you're boxed in for one reason or another. My recommendations include these. Make plans to move to a memory-optimized database technology because it is the direction we're going in. Eventually, pretty much all applications will go in that direction. It's not just about speed, remember, it's also about simplicity of operations. I know that some of you are probably wondering what this will do in terms of hardware cost, but the cost of memory is going down all the time. And as the ability of memory to handle increasingly large databases increases, the relative cost difference between memory and disk, while will continue to be great, will not be a factor when you consider it in relation to the other benefits of memory-optimized database. Plan how your data center is to be managed and administered over time. So it's not just a question of looking at one problem or one project and saying, we'll use this technology for this one. You need to have a long-range strategy that says how you're going to roll this technology into your data center over time. And you need to consider how the memory-optimized database that you choose will integrate with the rest of your environment. And of course, in thinking about all these things, you should include, based on the information that we have, IBM's DB2 with blue acceleration in your list of considered options. I hope that you found that presentation useful and informative. I'd like to hand things over now to Bob Frisk of IBM, who's going to take you a little more deeply into IBM DB2 Blue Acceleration on Power.
Thank you very much, Carl. Hopefully everybody found that information, very informative. Carl, again, comes with a lot of experience, and his knowledge in this area is vast and well-respected in the industry. And I think we all agree with what he's saying about the importance of in-memory database technology to analytical workloads going forward. What I want to do now is I'm going to walk you through IBM's offering and help align it with what Carl said to help you understand what our strategy is, how we're delivering this product, and how you might be able to use it going down the road for your analytical workloads. This first chart here is a high-level summary just explaining how it aligns with IBM's strategy and portfolio of products. And what this chart is trying to say, as we all understand, is that with this introduction of mobile, social, big data, cloud, it's introducing tremendous opportunities for clients, and it's also creating this vast amount of data. And companies like yours want to be able to bring this data into their business, analyze it, derive insights, and use those insights to steer your business decisions going forward. We would all love to get to a point where all of our business decisions were data-driven. And so that's our end goal. And IBM is very conscious of this and is investing very heavily in our analytics portfolio to ensure that customers can do this. And we're doing it in many ways by investing in applications, investing in hardware platforms, as well as investing in services and skills within IBM that we can share with you to help you deploy these types of solutions. Some of the examples that are listed on this page are things like working with natural language computing and cognitive computing. And these are technologies that IBM has done a really unique job of bringing to the market through IBM Watson. And IBM Watson was a terrific proof point, not just for IBM, but for the industry, to demonstrate the possibility of what analytics capabilities could be, within your company. And for those of you who didn't know, Watson used all in-memory technology. So all of the data was stored in memory so that it could deliver the analytics performance that was required when we took Watson to Jeopardy, and with what we've been able to do with the product since then. And so again, if you want to learn more about Watson, please go out to the internet and just search on the word IBM Watson, and there's tons of information out there. But again, that was our introduction of in-memory technology. And then from there, we wanted to make sure that we put it on a platform, on a server platform that was specifically designed for these types of analytic workloads. And IBM chose Power Systems because Power Systems has unique capabilities. It does massive I/O. It does parallel processing. It has the ability to handle the large amounts of data and with our large memory sizes. And not only that, with these mission-critical workloads, provide trusted resiliency. So it's not only the software applications you need to consider, but it's also the infrastructure that you deploy these software applications on. The latest technology we introduced is the one that Carl talked to us about today, which is the in-memory processing. And so what I want to do on these next several slides is introduce IBM's version of in-memory processing and show you what our customers have been able to accomplish with it. On this next slide, we're talking about the introduction of DB2 10.5, which is the latest release of DB2, which comes with a product called Blue Acceleration. Blue Acceleration is our dynamic in-memory capability. And what we did was we took this technology and we delivered on two platforms, Linux on x86 and AIX on Power. And we uniquely optimized both DB2 and Power Systems for this technology to deliver maximum performance. Some of the results we're seeing are things like 8 to 25x faster reporting and analytics. This isn't percent, this is times. So this is 25 times faster. And some of the benchmarks we did within our lab services organization demonstrated up to 1,000 times. So we're not saying that the average customer is going to get 1,000 times performance advantage, but what it is saying is that this technology has the ability to deliver game-changing performance for analytic workloads. And so what's the biggest investment customers are making now for these big data solutions? It's storage. Storage is growing phenomenally. And with this technology, we're also able to deliver a 10 times storage savings. and we're going to talk about exactly how we deliver that. So this provides not only faster performance, but it also delivers substantial storage savings, so a cost reduction. So let's look at the technologies that IBM introduced around DB2 with Blue Acceleration. Now remember, IBM is a company that invents technologies. We've always been a company that had a large number of patents, actually more patents than any other company in the world. And so we pride ourselves on being able to deliver this innovative technology to the industry to help steer the industry going forward. And DB2 with Blue Acceleration is a great example of that. So what we did within DB2 is we introduced 4 basic key technologies. One is dynamic in-memory. And as Carl mentioned, this is actually extending the database into memory. So what we do with this is we have the row technology still on disk, and we put the columnar technology in memory. And so within a single DB2 instance, I can run my OLTP workloads using the row technology and my analytic workloads using the columnar technology, and be able to reduce the amount of DB2 instances I have to maintain in my shop. So in addition to dynamic in-memory, we have actionable compression, which gives you the ability to compress the data and then use the data while compressed. Bottom left-hand corner, talking about parallel vector processing. Power systems designed for massive parallelism, and now with this technology, DB2 can leverage all of the massive parallelism of power systems to provide even faster throughput. And the last one is data skipping. And that means only load the data you specifically need for your queries instead of having to load all the data. So we introduced 4 basic technologies that help us deliver industry-leading performance for our in-memory database technology through Blue Acceleration. So let's go to the next page and look what some of these results are. So what this page is depicting here, in the far left-hand corner, we show a 10 terabyte data warehouse. And so this is my data I want to be able to use. Now, when I take those 4 technologies in the prior page and I apply them to this data, I use the actionable compression, the column processing, the data skipping, next row parallel processing, the vector processing, and the end result is I'm processing much less data. So we took all of this innovative technology, put it into DB2 with Blue Acceleration, and enabled not only to provide industry-leading performance and storage savings, but do it in ways that other vendors have not been able to bring it to market yet. So what does this mean to a customer? So what we really want to talk about is what are the early results customers are seeing. So this technology was introduced in the middle back in the June timeframe, and we introduced it on, again, Power Systems and x86. But let's look at some of the Power System results we had here. We talked on the prior page saying that the average customer will see between 8x and 25x performance improvement. Well, what did our customers see? To start out with, we had Blue Cross Blue Shield of Tennessee. They had a 43 times faster results with their analytic workloads. And what this means is that they took their queries, their troublesome queries that were running in production, they moved them into their test environment, they put them on Blue Acceleration. Without tuning, they just put them in there and ran the queries to see what kind of advantage they would see, and they got a 43x performance advantage. Fossil, what did they see? A 50 times performance improvement. In Coca-Cola saw 10x storage savings, 10 times storage savings. So again, these are just early customers who are trying the technology against some of their troublesome queries to see what kind of results they get, and they got phenomenal results. We have a lot more customers who are seeing these types of results also. And it's not just the performance and the cost savings, but it's the ease of deployment. One of the things that Carl talked about is how simple this technology is, and it really is. If you look on the left-hand side, those are some competing technologies. That's the way that you have traditionally loaded your data warehouse to get ready to drive your queries versus the right-hand side. As you can see from this example, it is super fast, easy, and you just have to create, load, and go. So it's not only performance advantage, cost advantage, but much, much easier than using traditional data warehouses. And the really nice thing about the solution from IBM is that this is on proven technology. As you all know, DB2 has been in the market for a long time. And you may or not have known, but Power Systems has been in the market for just as long. And so these are two well-proven technologies in the market that we just added this optimization in, and then for DB2 we added blue acceleration. And the two together provide a lot of value to your company. First, speed and simplicity. Just outstanding performance and fastest time to value. And we'll talk about how we're delivering this product to market and making it much easier for you to deploy. This is business proven. Again, these technologies have been around for a long time. And as you know, they both have a reputation for trusted resiliency. And so you're really minimizing your business risk compared to some of the competitive products, which are newer technologies being introduced in the market. And we have transparent scalability. Our solutions are capable of growing dynamically and transparently as your workloads grow. And I'll demonstrate that on another chart. And then not only do we provide lower total cost of ownership, but also lower acquisition costs. And some of that is demonstrated by the ability to have less data that's necessary to load into memory and less storage requirements. And we have some examples of that as we go through the rest of this presentation. But again, just emphasizing that this is not new technology that we're introducing to market, but instead new capabilities into existing technology. On this next page, this is an example of how we're helping to provide fastest time to value. This is a new solution offering we just introduced in October. And the solution is called IBM Blue Acceleration Solution Power Systems Edition. This is a brand new server we introduced called the Power ESE. It comes with the operating system, the virtualization technology, as well as DB2 with Blue Acceleration, pre-installed, pre-optimized. All you do is order it with one part number at a reduced price, and again, it's easy to acquire, easy to deploy, easy to implement. And the nice thing about this, as we mentioned, it has a capability called capacity on demand. So you can deploy this, for example, with 8 cores. If you want to start out with a smaller data warehouse, and then as your requirements grow, you can dynamically and transparently grow this, and you only pay for the additional hardware as you use it. So it's a nice way of putting a solution in and growing into it as your business requirements change. So how do the IBM solutions stack up against some of the competitive products? And we put a couple of different examples in here just to help you out. But on this first one here, this is not a in-memory technology, but instead is a very typical and popular analytics platform that many customers are considering deploying. And a couple of key things I want to point out here. First of all, the most obvious is on the right-hand side when we talk about the substantial cost savings with the IBM solution and the power savings. And that's something that we can explain within your shop if you allow us to come in and do a no-charge assessment. But let's look at a couple more interesting things. The first one is the picture in the middle. And you'll see that the IBM solution, because Power Systems was designed for analytic workloads, we can run more workloads on fewer cores and on a smaller footprint. And so you'll see that when many of our competitors have to have a full rack solution, we can deploy those same solutions on a single node. So that's one really, really key thing to keep in mind. Also, far left-hand side, if you look at the number of cores, you can see that IBM with Power Systems can run this solution on 16 cores, where the competition has to do it on 68 cores. Now, if you're using terabyte pricing, then, of course, this becomes less of a consideration, except for the fact that you're paying for much less hardware in Power Systems. But if you do have per-core pricing on some of your applications that run on those servers, obviously this can be a tremendous cost savings by running it on fewer cores on Power Systems. But how do we stack up against competitive in-memory technologies? And so this next chart is an example of that. And again, if you look on the far right-hand side, you can see that our solution is running 6.5 times faster at 14 times lower cost. And again, you can notice that we're running ours on 16 cores versus 40 cores. And there's a lot of technology reasons why we're able to run more of these analytic workloads on fewer cores. But the key thing to remember here when you look at these technologies and you're considering your infrastructure for your in-memory database technology is that Power Systems was designed for analytic workloads. And DB2 with Blue Acceleration, IBM's in-memory technology, was optimized to leverage those advanced features. So when you combine those two technologies, again, it's always nice when they're coming from a single company because they have the ability to work together. And we're able to deliver a solution that provides maximum value to our customers. Okay, we have a lot of information out there for you so that you can go in and learn more about these technologies. On this page here, I put a couple of examples. One is the DB2 website, and the other one is the Power website. A couple of comments I want to make in closing before we go over to the Q&A. To begin with, just want to let you mention that DB2 with Blue Acceleration is not limited just to SAP workloads. SAP workloads are one of the examples, but this works in any analytic workload. And again, as a reminder, and you can also run both the OLTP and your analytic workloads within the same database instance. So it can handle a wide range of workloads. Also, I want to mention that for customers who are running SAP, DB2 with Blue Acceleration is certified by SAP. So DB2 10.5 is certified for OLTP, and Blue Acceleration is certified for Business Warehouse. And so if you're looking at taking your testing these workloads and then moving into production, it's already well supported by SAP, so that should be no problem at all. Hopefully you found this information very informative. If you have any questions about this technology, we would love an opportunity to come in and do an assessment at no charge within your shop to help you understand how these technologies can help create analytics that really changes the game for you, that really helps you go from near real-time to real-time for your analytical workloads. We understand that these are becoming mission critical and that you have to find ways of improving the performance and the cost for these workloads going forward. I really appreciate Carl and all of his input he gave us today. Hopefully you guys all found this very informative. I know that I did. And we always love to get Carl into these calls because he provides just years and years of knowledge. And again, he's very well respected in the industry regarding his perspective on this. And he always adds a lot of value to these discussions. Again, if you have any questions, please reach out to your IBM direct sellers or your business partners, and they would be glad to bring a subject matter expert in to give you more information on this. What I would do now before we close is turn it over to our moderator for questions and answers. So if you have any questions, please feel free to ask us.
Thank you, Bob. As Bob did mention, we're now going to move on to the live question and answer portion of today's presentation. And we do encourage you to enter in your questions by clicking on the Questions tab, which is on the left-hand side of the screen, and click on the Submit Question button. And we'll respond to as many questions as time allows today. We did receive some questions during the course of the webcast, so we'll just jump right into it. Okay, and the first question that we have is for Carl. And Carl, this person would like to know, can I run my OLTP and analytic workloads in the same database instance?
Well, most of the leading database vendors, including those that offer some level of memory optimization, claim that this is possible with their technology. We've talked to a number of specialists in the area who offer practical support and database management to their clients as well as to DBAs themselves. And what we understand is that in most cases, it's very difficult actually to maintain the right level of performance and manageability for your databases when you put both analytic and transactional data in the same database instance because of the exquisitely complex tuning and separation of workload activities required. There are, however, notable exceptions to that. So I would say that in some cases, yes, and in other cases, no.
Thanks, Carl. This is Bob. Let me expand on that a little bit. The nice thing about the way that IBM chose to deploy this technology was we introduced it into our existing DB2 environment. So DB2, which was obviously already optimized for OLTP workloads, we added the blue acceleration in there. And so the real advantage we have over some of the competitive offerings is instead of introducing a brand new dynamic in-memory technology that they want to have the capability of running OLTP, we took our existing OLTP environment and added dynamic in-memory technology. So though, yes, some of the competing products are not quite there yet where they can offer the level of performance required to put these two mixed workloads together, IBM DB2 with blue acceleration has been able to deliver that. And it's a great opportunity for you to bring it into your shop, test it with the blue acceleration for your analytic workloads, and then go ahead and run your OLTP transactions against it and see just how well it runs in your environment.
Okay, thank you. And the next question we have is for Bob. Bob, this person would like to know, I already have DB2 running in my shop. Is there additional cost to move up to DB2 10.5 with BLU acceleration?
Yeah, that's an excellent question. And I know that cost is a big concern with customers who are looking at deploying these new analytic workloads. If you're an existing DB2 customer, they have a no-charge upgrade path to the latest release of DB2 10.5. So you just need to check with your software group representative to make sure that you're at the right level of DB2 to be able to leverage this. And if you are, then yes, DB2 with blue acceleration, the blue acceleration component, is part of DB2 10.5 and is included at no additional charge. So again, we want to make this as simple and as least expensive possible for customers to be able to move up into.
Okay. And another question here for you, Bob. This person runs their OLTP in an Oracle database. Can they still leverage DB2 with blue acceleration?
Yes, absolutely. And we know that a very large percentage of our install base is Oracle customers, and we really appreciate those customers deploying those workloads on IBM hardware. A couple things I want to mention there. First of all, yes, absolutely. If you continue to run your OLTP workloads in Oracle, that's perfectly fine. And you can install DB2 with blue acceleration within that same on that same server if you're on Power Systems, or within another server within your infrastructure, and you can take the data from DB2 and load it into DB2 with blue acceleration, and you can run them side by side. So Oracle running your OLTP and DB2 with blue acceleration run your analytics queries runs really well side by side. Just one more point I want to make on that also is that DB2 can run on existing hardware. So, for example, you don't need brand new hardware technology for this. So if you happen to have had your DB2, your Oracle running on a Power System server, you can take another partition on that server and put DB2 with blue acceleration and run them on the same server. Or if you have, if you're looking to deploy a brand new server, it can be supported that way too. So both existing or new hardware, and those two run great side by side.
Okay. And we have time for one more question today. And this question is for Carl from another Oracle user. This person's asking, we're currently using Oracle. If we try to bring in DB2, how do I prevent pushback from my DBAs?
Okay, so I'm assuming that all of my remarks about memory optimized database and the reduced need for operational complexity and special tuning is scary, which is understandable, right? Because DBAs have spent many years developing skills around tuning databases, and they see that as the thing that makes them valuable to the enterprise. But the truth is, and this remark, although it relates to the question about Oracle, it actually relates to the question in general about anybody who's developed expertise in a disk-optimized system. That there's naturally going to be some concern on the part of the DBAs there. What happens to me if we go to the system that doesn't require that skill set that I've spent 20 and 30 years developing? Well, it does, but in a different way, because what you're doing now is you're spending a lot of time optimizing your database for disk. You're spending a lot of time fine-tuning the index structure and deciding which indexes are global and which ones are partitioned. You're defining hash partitions and other kinds of semantic partitions and so forth. You're distributing and redistributing the data across disk volumes. And every time there's a change of any substance in the structure of the database, you execute those operations all over again. Well, what does this mean? while you're keeping the database running well, you're also doing something else, which is that when your business users come to you and say, we need to make a change to the data warehouse because we want to do a different kind of analysis, what is your answer? If your answer is, well, it's going to take me 2 to 3 weeks to make the changes, restructure the database, and of course I have to schedule the operations time during off-peak periods in order to execute the batch operations necessary to do all this, what they really hear is that you're an obstacle to their being more responsive to the business needs. If, on the other hand, you don't have those actions that you have to perform, if you have the time to get to the stack of user requests, and I know from talking to a lot of DBAs that there's always a stack of business user requests on their desk that they can't get to. Now you have transformed yourself from being an obstacle to being a hero, because now you're able to make those changes. You're able to help the applications folks make the behavior of the application more responsive to the needs of the business. You're able to help the data warehouse people make their queries more responsive to the shifting needs of the enterprise as it moves forward. And you're seen as an enabler rather than as an obstacle, and that is going to translate into, to be quite honest about it and blunt about it, it's going to translate into better career opportunities within the enterprise as you move forward. So I think that DBAs should feel empowered by the idea of moving to a memory-optimized database and not threatened.
Okay, thank you, Carl. Well, unfortunately, that is all the time that we have today. I would like to thank Carl and Bob again for taking the time to join us. I'd also like to thank IBM for sponsoring today's event. And as always, I'd like to thank you, the audience, for taking the time to join us. Have a great day.